Okay, welcome America, welcome India, welcome Taylor Swift. We are going to be reviewing the two types of special right triangles. So last class we learned about the Pythagorean theorem. When you're given two sides, you're asked to find the third side of a right triangle. Here we have what's called an isosceles right triangle. So the lengths of the legs are the same length. So this length is the same measure as this length. Notice they're both labeled S. The shortcut that we are given, it's already been worked out for us, is the length of the leg, those are the same, times the square root of 2 gives us the length of the hypotenuse. So we can just automatically know what it is. So if the length of this leg is 6, then this one also has to be 6, and this length would be 6 root 2. Done. The reason that works is because if I go through all the drama of the Pythagorean theorem, okay, and I plug these sides in, and I follow the Pythagorean theorem, and I take the square root of both sides, the square root of 2 times square root of s squared, square root of s squared is just s. I end up getting the length of the other side. So we can use the Pythagorean theorem, but special right triangles, they're special, there's a shortcut, and it's an easy way to find an answer. So that's in a 45, 45, 90 triangle. The reason we know this is 45, 45, 90 is because of the base angle theorem. Well, also they told us, but when the measure of these base angles are the same, the lengths of the sides opposite them are also the same. So we know that these sides are the same. So if we're given this is 45, 45, 90, we know the length of the legs are the same. Or if we're given the lengths of the legs are the same, this is a right triangle, we know this is a 45, 45, 90. Okay, so find the length of the missing sides. Okay, we are not going to do Pythagorean theorem, we're going to do our shortcut. We know this is a 45, 45, 90 triangle. So the length of these sides, base angle theorem tells us the length of the sides or the legs should be the same. Special right triangle, the length of the hypotenuse has to be 5 root 2. The length of the side times root 2. Now this one we are given the length of the hypotenuse. We're going to work backwards. If I have to go from the length of the leg to the hypotenuse by multiplying by the square root of 2, then to go from the hypotenuse to the length of the leg, I'm going to be doing the opposite operation, which is dividing by the square root of 2. So 7 root 2 divided by root 2 will just give us 7, and those lengths are 7. Now you might run into a trickier type of problem. I'm hoping there's one right below here, and there isn't. It's fine, I'll show you. So the length of, here's the right angle, right? That makes this leg and that leg, those lengths are 6. We know that because there's a 45 angle here. So that makes this angle 45. It's a 45, 45, 90 triangle. The lengths of the legs are 6, and the length of the hypotenuse is 6 root 2. Working backwards, here's the hypotenuse because it's across from the right angle. This is a 45, 45, 90 triangle because 45 plus 45 plus 90 adds up to 180. The length of the hypotenuse is 9 root 2, so we divide by root 2 and we just get 9 for the length of the legs. Now sometimes it's a little trickier, and let's say they told us the length of the leg was 9, okay? We still have to divide by root 2. So sometimes when you're dividing by root 2 or root 3, and then there's one more type of special right triangle where you may have to divide by root 3, you're going to have to rationalize the denominator. So we're going to have to multiply by special 1, which we've done this year. We know that's 9 root 2 over 2 because root 2 times root 2 is 2. And then this can't be simplified because 2 doesn't go into 9 evenly, so we're done, okay? So that does happen on occasion where you have to rationalize the denominator. Moving on to the second type of special right triangle. It's a little bit more complicated. This is a 30, 60, 90 triangle. And this type of triangle is the length of the sides are always, they revolve around the length of the short side. So the length of the short side we're in this triangle we're calling is S. We know that's the short side because it's across from 30 degrees. The 60 degrees, the side that's across from that, is the longer side. And the side across from the right angle is the hypotenuse. Now some people get this 2 and square root of 3 confused because this is a square root of 3, not an actual 3. So if you look at the numbers 1, 2, and square root of 3, they don't go in this order. 1, the next biggest number is not 2, it's actually root 3. So if I were putting these numbers in order, it'd be 1 and then root 3 and then 2. 2 is bigger than root 3 because root 3 is like 1 point and some stuff. So the root 3 goes with the long side, and the 2 goes with the longest side, which is the hypotenuse. So now, just have to have those links, that relationship memorized. So now we go to example 3 and example 4. We know this is 6 is the short side because it's across from the 30 degrees. If I take the 6 and multiply it by the square root of 3, I get the length of the long side. The long side is over here because it's across from the 60, so this is 6 root 3. The length of the hypotenuse is the short side times 2, so this is just going to be 12. That's the easiest type of problem where they give you the short side because you can just multiply it by the square root of 3 to get the long side and multiply it by 2 to get the hypotenuse. Sometimes they give you either the hypotenuse or the long side and you have to work backwards. So we went from the short side to the long side, we multiplied by the square root of 3. Here in this example 4, they've given us the long side because we know it's across from the 60 degrees. So that's the long side. We are going to get the short side. We are going to have to divide by the square root of 3. So if I take 7 root 3 and divide by the square root of 3, I'm going to just get 7, and then 7 times 2 will give me the hypotenuse, which is 14. And I'm going quickly, and you might have to rewind this to take a look at it. I think I'm almost finished. Yes. Now, again, sometimes you might have a problem where you have to rationalize the denominator. You may have to multiply by root 3 over 3 in some of these problems. So here, this 3, this is clearly the short side because it's across from the 30. So I can multiply it by the square root of 3 to get the long side. This is the long side because it's across from the 60. To get the hypotenuse, I have to multiply by 3 times 2, and I just get 6. Here I've been given the hypotenuse. The hypotenuse is across from the right angle. Over here, to get the hypotenuse, I took the short side and multiplied it by 2. So the opposite operation, to go from the hypotenuse to the short side, is going to be divided by 2. So 20 divided by 2 gives us 10. This is the short side because it's across from the 30 degrees, the smallest angle. And then this is the long side because the long side is across from the 60 degree angle. Here's the smallest angle. Here's the middle angle. Here's the biggest angle. The shortest side is across from the smallest angle. The middle side is across from the middle angle, and the longest side is across from the biggest angle. So this is 10 times root 3. And that's it. Peace out.